Hey guys, welcome back to doing ed puzzles. Alright, so we are going to go through factoring when the coefficient of x squared is not equal to 1. So we are going to do these 4 warm-up problems, and then we will start section 5.7, which is special factoring. So you guys have seen most of the formulas. There's 2 new ones today. So what I would like you to do right now is hit pause, take your time, and I would like you to factor these 4 warm-up problems. If you are stuck, go back and look at your notes from Tuesday. Alright, let's go through number 1 and we will see how we are doing here. So remember, A affects the 2 numbers you are using to find your combination here. So 2 times, this is supposed to be a 3, sorry if that was not clear. Alright, 2 times 3, so 2 numbers that multiply to get 6, and their sum is 7. So that is 6 and 1. So we are going to break up 7x into 6x and 1x. Keep everything the same. Now, grouping 2 by 2. 2x squared and 6x has a common factor of 2x. This is a little bit interesting. 1x plus 3. They don't have anything in common, but we need a coefficient, so we're just going to take out a 1. Oops, sorry. Made a math mistake here. 6 divided by 2 is 3. Alright, both of these 2 terms have an x plus 3. And then what we are left with are the coefficients 2x plus 1. We definitely need the second piece of our binomial, so we need that 1 there. Okay, number 2, 3, and 4. Go ahead and hit pause again if you need to. Look at what I did for number 1. Write down any questions you may have and try out 2, 3, and 4. Alright, so number 2. 2 numbers that multiply to get negative 36 and add to get 5 here. So maybe I'll move this down so I can see everything. Alright, so that is 9 and negative 4. Notice the 5 is positive, so the bigger of the 2 numbers, 9 and 4, has to be positive, so 9 is the positive one. Grouping 2 by 2, and you get 2y plus 3 and 3y minus 2. Number 3, 2 numbers that multiply to get 5 times 6, 30, and add to get 11. That is in fact 5 and 6. So when I choose, it doesn't matter what order you have here when you break up the middle number. To the 2 terms answer this question up here. However, I would say it's easier to group if you have the 5s together and the 6s together, so I chose to put 5 first. You'll still get the same answer, it's just a preference thing. Number 4. 2 numbers that multiply to get negative 12, and their difference is, or their sum is negative 4. It's a negative 6 and a positive 2. So hit pause and check your answers for these ones. Make note if you made any mistakes, and we can be sure to go over this in class next time. Alright, section 5.7, special factoring. Hit pause and write down all of these formulas here. The 2 new ones we have not seen before are the sum and difference of cubes. Alright, make note, we are always checking for GCF and then looking for special patterns. So, we have seen difference of perfect squares and perfect square trinomials before, but now look, we are going from the answer to the factored form. So we're going backwards, so definitely write them again, even though you have them in your notebook from before. When you are given two terms and asked to factor, we are going to be looking for, alright, is that difference of perfect squares, difference of perfect cubes, or sum of perfect cubes? Notice there is no formula for sum of perfect squares, so when that happens, look for a GCF. If there is no GCF, then it means it is prime. Let's try a couple examples to practice. Alright, number 1 and number 2. We know, because we've seen perfect squares a lot, so in our mind, when we see 25 and 81, a light bulb goes off and says, ooh, perfect squares. Off to the side here, let's just write perfect cubes down, so we have them fresh in our mind. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed 125, 6 cubed 256, 7 cubed 343, and that's all I have memorized or room for right now. So those are perfect cubes. When we see two terms, we want to think, alright, is it a cube or is it going to be squares? In this case, the coefficients in number 1 help us out. So when I see a difference of perfect squares, I write out what each of the terms are as their base being squared. So what squared is 25? That answer is 5. X to what power gives you 2? Well, 2. Y to what power? Y to the power of 2. What gets you there? The square root. So this is when you have a power to a power, you multiply. So we are dividing here. 4 divided by 2 is 2. Running out of space. So this is the square root of that individual term there. 81, the square root is 9. Notice I put in positive 9 here. The subtraction goes outside. So in green, that is my A in my formula, and my 9 is my B. So difference of perfect squares tells you to do A plus B. So green plus the blue. So 5xy squared plus 9, and then 5xy squared minus 9. This is the factored form of number 1. Number 2. 16 is a perfect square. Z to the 6 is a perfect square or a perfect cube. However, we have a plus sign here. So this is going to be prime. We do not have a formula for sum of squares. Pause and take note of your perfect cubes here on the right, or what I did for number 1. Do you need to do this working step here that I'm highlighting in yellow? Absolutely not, but if it helps you, please do so. Number 3. Try number 3 on your own there. Alright, remember, always take out a GCF first, so GCF of 5y, and then we have y squared minus 8y plus 16. Now, you have something back to what we did way back when last week, when y squared or x squared had a coefficient of 1. However, this is in perfect square trinomial form, because 16 is something squared, y squared is something squared, and 8 is twice those two multiplied together. So this is in fact y minus 4, and the fancy way to simplify that, condense it, is y minus 4 squared. Do not forget about your GCF. Final answer. Do you need to jump from the beginning to the end? Absolutely not. Take the time to write out the steps. Number 4. 27 was on our perfect cube list, and m cubed is a perfect cube. So think of this as m cubed minus 3 cubed. So m is our A and 3 is our B, and they in the perfect, the sum of two cubes formula. Let's go back. The sum of two cubes formula, wrong thing. Oops. So A is M and B is 3. So we are plugging in for that formula. We have a binomial and a trinomial. So we are going to get M. Oh, I just said sum, but it's actually the difference. I hit the wrong one. Not good. This formula. This is the one we want. Alright, so A is M, B is 3, so our formula tells us to do A minus B, so M minus 3, and the trinomial, A squared, our A is M, so M squared plus 3 times M plus 3 squared, which is 9. Please take a minute and digest that. Alright, take a few minutes and try to factor numbers 5 and 6. Do not forget about taking out a GCF. So number 5, GCF of 7, y to the 4th minus z to the 4th. Difference of perfect squares. This is y squared squared, so y squared plus z squared, y squared minus z squared. Do you notice anything about the factors that are left here? Do either of the two parentheses have the form of one of the formulas? This one here is difference of perfect squares. So y minus z and y plus z. You keep going until you cannot factor anymore. Someone last week asked, will everyone always have the same answer? The answer is yes for these ones. The order may have just be different. But you have to have all 4 of these factors. Number 6, take out a GCF of 2. In parentheses, that is in the form of the sum of 2 cubes. So what cubed is c to the 6th, and what cubed is 8d to the 8th. Oh, whatever, 9, excuse me. Divide, because power to power you multiply, so going backwards, this is going to be c squared. And this one, 2 cubed is 8, 9 divided by 3 is 3. Running out of room here, d cubed. So sum of 2 cubes, c squared plus 2d cubed, and my other factor is c to the 4th, because you're squaring your first term, minus these 2 multiplied together, plus our b term squared, so 4d to the 6th. Sorry, I'm running out of room here. So your final answer, 2 c squared plus 2d cubed, and c to the 4th minus 2c squared d cubed, plus 4d to the 6th. Notice that in both formulas that you wrote, sum of cubes, this middle number is a negative, and difference of cubes, that middle number is a positive. That is all I have for today. Hit pause and let me know if you have any other questions, and I will see you guys soon. Thanks.